In this video, I'm going to talk about drug elimination and bioavailability. Also, I'm going to talk about hepatic first pass effect. So, what is bioavailability? The word bioavailability, bioavailability, the word bioavailability means fraction of drug, fraction of drug that is available in the systemic circulation. In the systemic circulation. And that is independent of the route of administration. So fraction of a drug that is available in the systemic circulation after administration is known as bioavailability of a particular drug. So here we would draw a diagram and we will take a look at two routes of administration. One is oral and one is intravenous, and we would see how the bioavailability differs for these two paths. So here I'm drawing a simplified diagram for a heart. So here is the simplified diagram for our heart, and say for instance this is our liver. This is our liver, and here is our hepatic so here is our liver, and here is our hepatic artery, and we have here our hepatic vein, and also here we have the intestine, and from intestine to liver we have the hepatic portal vein, hepatic portal vein, and this is the hepatic artery. This is the hepatic portal vein. This is the hepatic vein, and so this is the systemic circulation, and this is the portal circulation. So when a drug such as this tablet is as administered in the oral route, so it would go into the gut and it would be absorbed into the intestine. When it is absorbed in the intestine, it would go straight via this hepatic portal vein to the liver, and in liver biotransformation of the drug would happen, and a drug would become more solubilized by addition of a series of reaction, phase 1 and phase 2 biotransformation reaction, and that would be excreted in the urine. So before getting available into the body in the systemic circulation, the drug is eliminated by the liver. So this effect is called first pass effect. In contrast, if we see another mode of administration, that is our IV administration, that means intravenous administration, then our drug is directly available into the systemic circulation. Our drug is directly available in the systemic circulation. In contrast, our oral route, the drug is not that much available in the systemic circulation because liver eliminates the drug. A lot portion of the drug is eliminated by the liver. So here we are trying to draw a graph and try to visualize how availability of the drug affected in case of oral administration and IV administration. So for instance, it is our oral administration. So here we have time in the x-axis, and we have the drug concentration on the y-axis. So this is for our oral administration, and here is the Cmax value for the oral administration. In contrast, for IV administration, the drug would be more available to the body, so the drug have a higher Cmax value in contrast to the, so this would be for oral administration, and this would be for IV administration. So bioavailability for the IV administration would be far greater than the drug which is administered orally. Now we will try to see the kinetics of elimination, of drug elimination. So our drug elimination kinetics could be broadly divided into two categories. One is first order elimination and other is the zeroth order elimination. So let's see the first order elimination. So say for instance we have a drug concentration of C. So the first order differential equation would be dc dt would be some constant over C. So the elimination is dependent upon concentration. So it is written as dc dt equal to minus kc. So now if we just uh, do the math, and if we integrate it from C0 to Ct, where Ct is the drug concentration after a time t and C0 is the initial drug concentration, and we integrate it over a time 0 to t, we would have ln, that is natural log Ct C0 equal to minus kt. And if we just analyze and rearrange it, we would have Ct by C0 equal to e to the power minus kt, and Ct would be C0 e to the power minus kt, or we can write it as e to the power kt. So from this equation, it is quite evident that drug concentration at time t is less than the initial concentration. So the concentration of the drug is less at time t, and that is the sense of elimination. So if we just draw the graph for that, for the first order elimination, if we try to draw the graph, and this is time and this is drug concentration, I mean concentration is C. So what would happen with the increase of time? The drug concentration would fall. So this is the first order elimination reaction. In contrast, if we have a zeroth order, so this is our first order elimination. If we have our zeroth order elimination, then our elimination rate, rate of elimination, that is dc dt, is independent of the concentration term. So our dc dt is actually constant. So dc dt would be constant. Now if we try to draw the graph of drug concentration over time, then it would be a straight line. So it actually doesn't depend upon the concentration of the drug. So for the first order kinetics, if we have more drug in our body, in our system, then the rate of elimination would be faster. But in contrast, if we have, for the zeroth order, the drugs that follow zeroth order kinetics, if we have greater amount of those drugs, and that drugs won't be eliminated very easily because they would be eliminated at a fairly constant rate. Their rate of elimination is constant. Say for example, the zeroth order drugs are alcohols. So alcohols follow the zeroth order kinetics. And what happens, say for instance we have 100 ml of alcohol, and the elimination rate is 10 ml per hour. So to eliminate the whole amount of alcohol, we need at least 10-hour time to eliminate the whole alcohol. Apart from alcohol, many other drugs also follow the zeroth order kinetics, but it is quite harmful because the drug stays for a lot of period in the body. So it could result in a huge amount of toxicity. Whereas if we talk about zeroth order kinetics, the drug elimination is quite faster with respect to zeroth order kinetics. The first order kinetics, in the first order kinetics, the drug elimination is quite faster. And just to summarize the hepatic first pass effect, hepatic first pass effect should be considered as a very important fact, because many drugs we cannot be administered in the oral route because of this hepatic first pass effect. For example, morphine cannot be administered in the oral route because most of the administered morphine would be eliminated by the liver. That is why morphine have to be administered by the IV route instead of the oral route. Hope you liked it, you have enjoyed, and please like and don't forget to subscribe.